When we consider our perceptual systems and our action systems in relation to those of other animals, I think we see enormous similarity. So much similarity that animal models have told us a great deal about how it is that we perceive and act in the ways that we do. But when we turn to our cognitive systems, it seems like there's this huge chasm between us and all of the other animals. Every animal has to deal with physical objects, but only we surround ourselves with artifacts. There may not be a single natural object in this room except for the people who are here. All animals have to find food, but only we develop cuisines of the wonderful sorts you have in California, and of course the list goes on. And this raises the question, what propels these differences? And that question has proved extremely difficult to answer, because for every one of these things that marks us as a species, you can find individual cases where other animals will use tools or will prepare food in some interesting way, or even if they're Dr. Matsuzawa's chimpanzees, read numbers better than we do. But still, I think what seems really special about us is the way that we systematically and flexibly and prolifically develop new systems of concepts, whole systems of concepts. So the question I want to raise is what propels these differences? And I should put in a disclaimer at the very beginning. I'm not going to answer this question. What I want to argue, though, is that the question's answerable. It's answerable with the techniques that we currently have. And to illustrate that argument, I want to contrast two different answers to this question. So the first answer, which I think was articulated most compellingly by Jason just 2 talks ago, what distinguishes us is our social minds, our abilities to read each other's minds, and through these mind-reading activities, to develop ways of cooperating and competing with one another, of exchanging goods and information, of teaching and learning from one another. I think this answer has a good chance of being correct. But I want to contrast it with a different answer that I'm going to argue for today. And that fundamentally, what makes us special is not anything that's specific to the social domain. Rather, it's our general combinatorial capacity that we can apply to any domain to carry cognition far beyond the bounds that it reaches in other animals. So more specifically, what I'll suggest is that, like our perceptual systems, we have basic cognitive systems, basic systems for making sense of abstract properties of the world that begin in a state that's largely the same as the cognitive systems of other animals. But we alone, over the course of cognitive development, come to combine the products of these systems, the properties of the world that these systems serve to represent, flexibly and productively. And through these combinations, we create new systems of knowledge. Now, this is a view that's been suggested, I think, by research very far from social cognition, research in mathematical cognition, and it's come from studies where people have tested the numerical and geometrical capacities of infants and other animals, and have found evidence, perhaps surprisingly, for capacities that exist at the beginning of human life that remain present and functional in us throughout our lives, and that we draw on when we perform symbolic mathematics or reason about Euclidean geometry. But nevertheless, when we look at these capacities in infants, they look strikingly limited. We see 2 distinct systems for reasoning about small numbers exactly and large numbers approximately, 2 distinct systems for reasoning about the shape of the layouts that we navigate through versus reasoning about the shapes of objects that we recognize. These systems are elicited under different conditions. They make available different kinds of numerical or geometrical information. And most deeply, they answer different questions about the world. Yet, despite their differences, somehow, over the course of childhood, children productively combine their 2 number systems to learn counting and arrive at the set of natural number concepts that will allow them to go to school and learn arithmetic. And somewhat later, they productively combine their 2 systems of geometry to arrive at the basic intuitions about points, lines, and figures on the Euclidean plane. And it looks like these developments happen hand in hand with the development of important symbol systems, especially natural language, but also spatial symbols of various kinds. So can an account like this be developed to explain our uniquely human social cognitive capacities? Well, here's my stab at an attempt to do this. I think there may be 2 systems by which infants understand other people. One is a system for representing people as agents who act on the world and cause changes in it. And the other is a system for representing social beings who engage with other social beings and share experiences with them. Like the core number and geometry systems, these systems serve to answer different questions and do so, I think, by drawing on different notions of mental states as intentional relations to the world in one case and as shared phenomenal experiences in the other. I hypothesize that neither of these systems is unique to humans. They both evolved long before our species did and will be found to be shared by other animals, and that they're largely separate from each other, both for human infants and for other animals, except in the many dramatic cases where animals learn smart ways of putting together piecemeal representations from these different systems. What I think distinguishes us is that we come to combine these systems flexibly and productively to create across the board a family of notions of mental states as both intentional and phenomenal, mental states that can take other mental states as their objects and therefore potentially infinite in range. And I want to end just by suggesting that this new conception may arise with and depend on the acquisition of language, and that it may account for the slow development of mental state reasoning. So let me quickly introduce you to these systems as they would appear from current research, that from an early age, 3 months in those gorgeous mitten studies, infants represent actions of reaching for objects as directed to their goal objects. They also represent actors as causing changes in the motions of objects. This is a study by Rebecca Sachs, where she first introduced kids to an inanimate beanbag and then let them see events in which the beanbag flew onto a stage. And the question was, what made that beanbag go? And to get at what infants thought about this, she subsequently showed them a hand that appeared either on the side that the beanbag came from or the other side. And they reacted differentially to those two events in a way suggesting that they expected that it was a person with a hand that had set that beanbag into motion. She and others have also shown that infants represent actions as constrained by barriers and as efficient. So if a barrier is taken away, they expect a direct action, a direct reach for an object in its absence. And finally, research suggests that infants represent actions as constrained by or dependent on visual access. So if an infant is presented with a person and two objects under conditions in which the person had an opportunity to see both of those objects, then the infant represents that person's action of reaching for one or the other object as dependent on both objects. But if in the same physical situation, the person only had a chance to see one of those two objects, the infant's prediction about the person's action is different. Now, I think in each of these cases, animals have not systematically been tested in all these cases, but where they have been, they've been found to have the same abilities. So newly hatched and controlled reared chicks have shown the first three abilities that I laid out there, and other animals have shown this sensitivity to visual access, as was talked about earlier today. But what we learned about core systems of mathematics is that they're limited. And we can ask, is that true for core systems of social cognition as well? And here's one limit that I think strikingly distinguishes the infant system of agent representation from our own. First of all, as I said, rather early on, infants take account of visual access in predicting what someone will do. But until the ridiculously old age of 14 months, they don't take account of where someone is looking. So if a person is presented with two objects that are visually accessible, turns to look at one of them, they predict equally that the person will reach for that object and reach for the other object. Relatedly, between the ages of 5 and 14 months, there's a very slow development of infants' ability to track a person's gaze to an object. And until 10 months of age, it seems like what they're tracking is not what the eyes are doing, because if a person closes their eyes and turns their head toward an object, they'll track it just as well. What's more, infants take reaching to be goal-directed as early as 5 months of age. They don't take the act of looking at an object to be directed to that object by the same measures until 12 months of age. So it seems as if infants don't understand that agents see objects. But you might ask, is it just that infants are insensitive to the eyes? They just don't care about the eyes in general. That is emphatically not the case. Because even a newborn infant responds differently to a photograph face of someone who is looking at them versus looking away, What's more, newborn and 3-month-old infants, if they're shown someone who first looks at them, then turns to look to the side, and then disappears, and an object either appears on the side they were looking at or the other side, they look faster to the side where when the object appears on the side where the person was looking. Now, interestingly, infants only show this pattern if they're presented with a face, and if the face starts by looking straight at them. Okay? This depends on initial gaze. So does infants' patterns of imitation of other people. The famous studies of Andy Meltzoff showing that if he performs a facial gesture, infants will, as young as newborns, will tend to reproduce it. Other studies have shown that infants from birth will tend to reproduce other people's vocalizations as best they can and their emotional expressions. But interestingly, in all these cases, this pattern of imitation is only shown when the person starts by looking at them with direct gaze. So gaze clearly matters for infants, and the question is how. Before I get to that question, let me mention that gaze matters for other animals too. In all of these respects, these early abilities that we see in human infants are seen also in other animals. So infant monkeys distinguish a face that's looking at them versus looking away, so do chicks. Adult monkeys show the attentional pattern when the face looks to the side, they look faster to the object. And although Tetsuro told us that infant chimpanzees don't adult chimpanzees don't ape, by which he means they don't reproduce other animals' actions on objects, neither do young infants. But chimpanzees, like human newborns, do imitate facial gestures, and his lab showed that beautifully. So do infant monkeys. And the question is why? Here's my suggestion. What we are seeing in these cases is the work of a different system, not for identifying agents who are going to make changes in the world, but social beings with whom one can enter states of engagement. For an infant, social beings may signal their engagement by direct gaze, by engagement in common actions, and when they're engaged with each other, social beings may share states of attention and possibly also states of emotion. Not states relating them intentionally to external objects, but states that directly relate one social being to another. So this is the hypothesis. Do infants have a system for representing social engagement? And with Lindsay Powell, a grad student and then postdoc at Harvard, I attempted to address this question by pursuing a possible implication of it. We know that infants are very limited in their behavior early on, but they're able to see the world reasonably well. So infancy seems like a good time to start to learn to navigate the social landscape. So we asked whether young infants, 4-month-olds in our studies, would use information from other people's patterns of behavioral indicators of social engagement to make predictions about who would interact with whom. So here's the first study that we did. We presented infants. In all these studies, we used simple cartoon characters so we could get good control over the stimuli and avoid the possibility of earlier learning about specific kinds of social patterns. So we have 2 blue guys who jump, and 2 red guys who slide, and a purple guy who responds to each of the other guys, but only by engaging in one action. For half the infants, he jumps. For the other half, he slides. And then infants see the purple guy approaching each of the other 2 groups and dancing with them. And the question is, who will the person approach? We record their looking time and find a reliable difference in the direction of longer looking when the person approaches the people that he imitated, the people with whom the infant sees him as being in a state of social engagement. We also showed the same thing in studies where what the imitative action wasn't a motion, it was a sound. Otherwise, the structure was the same and the effects were the same. It looks like infants expect copiers to engage socially with the social beings that they copy. We also tested the reverse inference. Do infants expect that if they've seen people engaging socially, do they expect that they'll imitate each other's actions? To get at this, we went to slightly older infants and a more complicated paradigm. Now there are 6 characters in 2 groups. Each of the 2 groups dances with each other separately from the other group to set up that there's 2 social groups here. And then the top 4 characters in each group circle around one box. And what distinguishes the two groups is which box they circle around. For half the infants, everybody circles around the nearer box, for the other half, the farther box, but always there's one box that's specific to each of the two groups. And then it's the test time, and the two guys who are at the bottom each in turn go to the center of the display and circle around the same box. So one guy is circling around the box that his group members circled around, the other guy is not. And once again, at two ages with two slightly different methods, we see evidence of infants expecting the social engagement to go with imitation. Further studies that Powell did showed that these expectations are specific to social beings. Infants don't show them when they're shown groups of inanimate objects with similar properties that move together. Interestingly, they also don't show them when they're shown agents who move independently, undergoing the same kinds of motion as in the social conditions, but who aren't grouped together. They have similar properties, but they're not grouped together. In those cases, no consistent expectations. So it looks like infants are expecting engaged social beings to copy their own group. Now, if this is a system like the other systems we find in infants, it should have some puzzling limits. And we found a few interesting limits. I think I have time to tell you just one of them. I've shown you evidence that infants expect copiers to affiliate with their targets. If one guy acts and another guy copies him, they expect the copier to approach the target. But if you simply reverse the order of these events, you see that infants do not expect targets to approach their copiers. So in this event, the purple guy acts first, and then either the blue guys copy him or the red guys copy him, and then he approaches either the blue or the red guys. Now, an adult might expect that social relationships are symmetrical and reciprocal, and you should get these effects in both directions. The infants don't show that. And the limit is kind of striking because infants actually like other people who imitate them, but they don't seem to attribute that imitation with that kind of causal effect. I think these studies suggest that infants see imitation as a sign of social motives in an imitator, but not as a cause of social motives in the target. So those are the only experiments I want to describe. Let me briefly point out some of what I think they suggest. First, they suggest that infants' social understanding is distinct from their understanding of agents and their instrumental actions. Distinct in one way that I just described, infants endow agents with powers to cause changes in the world, but they don't seem to endow social beings with powers to cause changes in other social beings. They also expect social beings, but not agents, to copy one another's actions. Research from other laboratories shows that infants like others who imitate their social gestures, but not others who imitate their actions on inanimate objects, at least not until about 14 months of age. And I started with the observation that infants are sensitive to gaze in social context, but not in the context of acting on objects. So what I want to propose is that there may be two systems of social cognition at work in us, starting from the beginning of life. One focusing on agents who act and intend, the other focusing on social beings who engage and emote. And neither of these systems, I think, as far as they've been tested, and they haven't been completely tested, is unique to humans. Now, where do infants go from here? Starting at about 9 to 12 months of age, we see some abrupt changes in infant social behavior. As many people have pointed out, they start sharing attention with other people to objects. They start pointing at objects and understand other people's pointing. They start understanding the act of giving an object as a social action, a friendly thing for someone to do. They start understanding helping and cooperation. And I think in general, what's going on in these cases is that social gestures are beginning to serve instrumental ends, and instrumental actions are beginning to have social meaning. And I gave some examples of that, but I'm out of time. So let me just end by asking, what could be causing these changes? Well, here's an observation. The rapid changes coincide in time with the onset of language. We now know that much earlier, by about 6 months of age, infants are starting to learn individual words, starting to learn to recognize individual words, typically names for objects and social terms like hi and bye-bye. But at the end of the first year, they're understanding when other people combine them together into sentences. And I think that this new understanding of people as being at one and the same time agents who represent the world of objects and social beings who share experience with each other may emerge as infants come to see speech acts as having both these social and object-directed properties. If that's right, then this combinatorial system also could explain why later social development looks so crashingly slow. And for this, the Sally Ann task, where should Sally look for her toy? Well, first of all, notice that Sally and Anne are there together and they're imitating each other. They've both got their hands raised. There's every reason to think that they're social partners. Now, if the child views Sally purely as an agent, then visual access says she should look in her basket. If she views her as a social being engaged with Anne, the social system says she should do what Anne does. Anne went to the box with the object, Sally should go to the box for the object. But if you see Sally as a social agent who shares attention to other social agents so as to gain accurate information about the world, then they should predict that they'll go where the object actually is. 2 of these 3 possibilities give the wrong answer in the false belief task. In general, I think that once children have this productive system of mental state concepts, they have multiple ways of construing the states of other people, as we do as adults. And this creates an enormous problem for child learners and also actually for adult reasoners. So, I am done. What makes us different? I don't know. The hypothesis, it's not our distinctive ways of, innately given distinctive ways of construing the social world. Instead, it's something about the distinctive way in which we create new systems of concepts from older ones. And this may account both for the slowness of our cognitive development and for the chasm that separates us from other animals. But more than I care about this point, I care about the effort that could lead us to come to know whether this story or a different story is right. That could lead us to come to know what it is about us today that distinguishes us from other animals today and accounts for our unique intelligence. And I hope I've suggested at least one way of going about this by looking at these creatures who are so radically different from us in everything that they know and yet so radically like us in everything that they are. But understanding them in the context of 4 different comparative enterprises: comparisons across animals, comparisons over human development, asking what's constant and what changes, comparisons across people living in different circumstances or navigating the world with different cognitive capacities, and especially comparisons across levels of analysis. Thank you.